Hello. Now we are going to start our next topic, that is electric flux. What is electric flux? Electric flux is the total number of electric field lines of force that is passing normally. Just mention this word normally, that is passing normally through that area. Actually, the electric flux acts for an area from which we need to find out how many electric field line of force is passing through that area. Not anyhow, only normally. The number of electric field lines that is passing the area normally is known as electric flux, and it is denoted by phi, and phi equals to what? Electric field into delta S. You can see delta S over here. The delta S is nothing but the area component, the component of area. You can see the first diagram. There is a diagram over there like rectangle. It is not a rectangle at all. It is a parallelogram, and you can see the number of line of force coming from left hand side, and it is crossing that area. Here in this diagram, the direction of both electric field and angle is same. The electric field lines are having a same direction as that of the area, so the angle between them is what? 0 degree. Okay. But in the next diagram, the lower one, you can see the electric field is making an angle theta with the area. So the component, which component we will take, sir? When we know that whenever a vector makes an angle, we have two components, E cos theta and E sin theta. Here we will take the component which is acting along the direction of area, that is E cos theta. So from here, what will have be the phi, that is flux, electric field into the area, that is E cos theta into delta S. So we can write it like this, E delta S cos theta, and we know that cos theta is a dot product, so it will be E vector dot delta S vector. The unit you can find from here, you can see Newton per kilometer square or voltmeter. Now the last theorem of this chapter, Gauss theorem. What is Gauss theorem? Actually, the Gauss theorem acts for a closed surface. The total flux through a closed surface is 1 by epsilon times the net charge enclosed by that surface. Okay. Suppose if there is a closed surface over there of electric field, so if you want to find a total flux, the total flux will always be equal to 1 by epsilon naught times the total charge enclosed by that surface. It is phi E, you can see over here phi E. Phi is what? The total electric flux equals to closed integration. You can see a sign over the integration. It is a closed integration because the Gauss theorem acts for a closed surface only, E vector dot ds vector. Okay, and it is equals to, as you can see know by the theorem, 1 by epsilon naught times the charge, that is q by epsilon naught. We can also prove it. See in the diagram, we have taken a small area ds. Okay, the radius of the circle is what? Small r, and in this diagram, electric field and area both are acting along the same direction. Okay, so the angle between them is what? Angle will be 0 degree, and from, if you want to prove it, electric field is equals to what? 1 by 4 pi epsilon naught q by r square. So theta will be equals to 0 degree. D phi E, what formula we have? E vector dot ds vector, that is E ds cos theta. It will be E ds, but it is ds over here, so we need to integrate it. When we will integrate it, we will not be integrating electric field, we will be integrating the ds only, and the integration of ds, as all of you know, it is S only. What is S representing over here? The S is the area of the closed surface. Okay, and it is a sphere, so the area will be what? 4 pi r square. Okay, so at the place of electric field, can we keep right over there 1 by 4 pi epsilon naught q by r square, and 4 pi r square is the area of the sphere. So 4 pi will be cancelled, r square will be cancelled. What we are getting at last? Q by epsilon naught. Proved. That was the Gauss theorem only, and we proved with the help of electric field. That is, the total electric flux through an enclosed surface is 1 by epsilon naught times the total charge enclosed by that surface. Now there is a question for you, there is a homework for you. Prove Coulomb's law from Gauss theorem. You have to prove the Coulomb's law with the help of Gauss theorem. This is your homework. You can take the first question of your worksheet. Now with the help of Gauss theorem, we will find two things. Okay, suppose there is a long charged wire which is infinitely long. Okay, because of that long charged wire, you need to find the electric field at a place, and you will be using Gauss theorem for that. But we know, sir, that the Gauss theorem we can use only when it is a closed surface. The electric charge is not the electric charged line wire is not at all the closed surface. So what we are going to do, taking it as center as axis, we are drawing a cylinder around it. You can see that I have drawn a cylinder of length L and radius small r. Okay, and you can see there are three surfaces. Surface 1, that is the curved path, surface 2, that is the upper circle, and surface 3, that is the lower circle. We need to find the electric field at the point at any point due to this long charged wire. So as you can see, electric field line is acting along the right hand direction. Okay, and the direction of the area for that, we have taken three surfaces S1, S2 and S3. The direction of all these areas are different. As the S2 is the upper circle, so direction will be what? Vertically upward. As the S3 is the lower circle, direction will be what? Vertically downward. Okay, for these two surfaces, you can see that the direction of electric field and these areas are at right angles. So the angle will be what? Theta equals 90 degree, and cos 90 we know, all of us we know what? The cos 90 will be equal to 0 degree. Okay, but the area S1, here the electric field and the direction of area is all both acting along the same direction. So angle between them is what? 0 degree. If the angle between them is 0 degree, then we know that value of cos 0 is how much? The value of cos 0 is 1. With the help of these three things only, we will find the electric flux first, then from the electric flux we can find the electric field. So if you want to find electric flux, what is the formula? Closed integration of E vector dot ds vector, and there are three surfaces, so we will divide into three parts, S1, S2 and S3. You can see over here, closed integration of S1, closed integration of S2 and closed integration of S3, E vector dot ds1, E vector dot ds2, E vector dot ds3, and the angle between two of them is 90 degree, angle between them one of them is 0 degree. So in the first case, electric E ds1 cos 0, but in the next two it is 90, and we know that the cos 90 is 0 at all. So these two will be vanished from there. What is will be left? Only the first one, E ds1. Again we will integrate. Then what we will integrate? We will integrate ds1. The integration of ds1 is what? S1 only. S1 is what? S1 is the curved surface, and we know the curved surface area of a cylinder is what? 2 pi rl. So we are placing it over there, E into 2 pi rl. Okay, this we found what? This we found the electric flux. But our question is what? Our question is to find the electric field due to the long charged wire. So we will take help of Gauss theorem over here. We have found over here electric flux, but from Gauss theorem also we know that phi equals to q by epsilon naught. So both the things are same. If the left hand side are same, we can equate the right hand side also, that I have done over here. E into 2 pi rl equals to q by epsilon naught, and here LL will be cancelled. So E will be what? E will be equals to 2 pi lambda by 2 pi r epsilon naught. What is lambda, sir? Lambda is known as linear charge density. Okay, or you can say charge per unit length. So lambda is what? Lambda equals to q by L. So q will be equals to what? Q will be equals to lambda L. Okay, then we will place the value of q over here in this part, that q will be replaced by lambda into L, then L will be cancelled, and we will get E equals to lambda by 2 pi r epsilon naught. Okay, here we have used Gauss theorem. One more place we will use Gauss theorem. This is this one. Again we will find electric field due to a uniformly charged infinite plane sheet. There is a plane sheet you can see over here in the middle. Okay, we need to find the electric field due to this plane sheet. Okay, again here we are taking two areas. We have drawn a cylinder because we know that the Gauss theorem is valid only for a closed surface. So we have drawn a cylinder over here. Okay, remember there we took lambda as a linear charge density because there was only length. Here this is a plane sheet. Here area will also be there. So we will take what? Sigma. What is sigma? Charge per unit area. This is known as what? Surface charge density. Charge per unit area. Sigma is equals to Q by A. So Q will be equal to what? Sigma into A. As you can see over here, there are two areas on the left hand side, on the right hand side. In both the areas, electric field is acting along the direction of the area only. So here in both the cases, the angle between them is what? 0 degree only. So phi will be what? Equals to EA plus EA. Okay, here nothing will be cancelled, as in the earlier cases we cancelled two things over there because of angle of 90 degree, but here we are not cancelling anything because here in both the cases the electric field and area is acting on the same direction. Okay, so EA plus EA will be equals to what? 2EA, and we know that again from the flux of Gauss theorem that it is Q by epsilon naught, but Q we have already done, that Q equals to what? Sigma into A, because sigma is a what? Surface charge density. Then 2EA will be equals to Q by epsilon naught, that is equal to sigma A by epsilon naught. That A and A we can cancel and we can find E equals to sigma by 2 epsilon naught. This is the electric field due to a uniformly charged infinite plane sheet. Again there is a question for you, the second question you can say, and second question of your worksheet, that find the electric field due to a uniformly charged thin spherical shell at 3 points, inside, on the sphere and outside the sphere, using Gauss theorem. Okay, that is it for this chapter. Okay, I am ending this chapter over here. I will try to give you some numericals also, some 3 or 4 basic numericals also I will discuss with you. Okay, and after that I will be giving you the worksheet as early as possible. Just prepare for your exams, prepare for your